This is part 2 of our sample projectile problem. We have the same situation as before. A cannon fires a cannonball at 30 meters per second at an angle of 25 degrees. But now, instead of knowing how long it goes, how far it goes, we're trying to figure out how high the cannonball goes. So we're not looking at the entire path of the cannonball here. The cannonball goes up, and it's going to come back down. But all we care about is this first half, when it gets to the highest point. We're only interested in the first half of this path. This is the highest point here, and we want to know what its height, its vertical displacement will be. So we're looking for delta y at this point. We can ignore the second half of the flight of this projectile. As the ball goes up, its velocity goes from here to here, to here, to here. At its highest point, its velocity is totally horizontal, which means its vertical velocity is 0. And that's the key to solving these problems. At the highest point, the vertical velocity, VYF, equals 0. From the projectile practice problem number 1, we figured out VYI was 12.7 meters per second, and Vx is 27.2 meters per second. We also know the acceleration, of course, negative 9.81 meters per second squared. So we should be able to use this information to find our delta y. We're looking for delta y. We know VYF, VYI, and the acceleration. So what's not part of this problem is the time, delta t. We're going to use the equation that doesn't have delta t in it. VYF squared equals VYI squared plus 2a delta y. Now it's just a matter of plugging and chugging. 0 squared equals 12.7 squared plus 2 times negative 9.81 delta y. Quick calculating. We end up with a maximum height of 8.22 meters. That's it.